So I'm going to talk to you today about the collaboration between the human and AI. And I think it's important that we consider what are the tools we're creating, because the tools that we create today are going to shape humanity moving forward. You know, as Winston Churchill says, we shape our tools and then our tools shape us. So thinking about what tools we're making today and what types of intelligence we're encoding into our future is really important. When we look at the tools that we're building, AI, the effort required to build AI requires a very specialized type of knowledge called computer science. And if we look at the global population of 7.8 billion people, we see that only 80 million of us actually know how to generate computer code. And of that 80 million, only about 95% of them are males. So we're excluding a large population from participating in both encoding of intelligence as well as leveraging that intelligence. In addition, the type of AI that we build today, the machine learning, really excels at linguistic data and visual data, which comprise all of the written and recorded lectures that exist out there, which is very helpful in terms of encoding literature knowledge. But it's eliminating a large amount of knowledge known as physical knowledge that humans possess. And when we look at really advanced abilities such as surgery, we see that you need both of those, both the literature knowledge and the physical knowledge, to create that really powerful judgment and capabilities that surgeons possess. Now, that physical knowledge is really difficult for us to encode, as Lama was just talking about. You know, that free form, unconstrained physical movement is really difficult to capture and leverage. But we actually have entire groups of people that are incredibly talented at thinking with their hands, quote unquote, right? And that ability to think with our hands is not just an illusion. It's not just something we say. It's a real thing. People think with their entire bodies. It's called embodied cognition. Now, embodied cognition is a growing area of research, and it shows that humans think as much with their fingers and toes as they do with their brains. In fact, you have just as many neurons in your gut as you do in your brain. And the more we engage that embodied cognition, the more effective our brains become. So, for example, if you're stuck on a problem and you go for a walk, you're twice as likely to solve that problem than if you are to sit still. Actors are encouraged to walk as they memorize their lines because that helps them to embody the knowledge of that content. Now, we know how to make tools that work with that embodied cognition through something called ergonomics. Ergonomics match systems to human capabilities to reduce the amount of input effort and amplify that output. Think about it like a hammer. A hammer fits perfectly into your hand and allows you to capture the energy of swinging your arm and amplifies that output dramatically without having to stop and think about the operation of the tool. Now, in order to sort of really amplify human capabilities, we create things called kickers. Okay, so kickers are ergonomic affordances that reduce the prerequisite specialized knowledge so that humans can be creative, ingenious about how they apply their knowledge to situations. So, for example, instead of this snow or waterboarder having to figure out, how the mechanism of being able to launch themselves into the air and having that be a kind of prerequisite to be able to actually do these amazing tricks and things that humans can do, we create a kicker that launches the person into the air. So they're not relying on their own abilities to launch themselves. They're able to launch off of this kicker and do those amazing tricks. When it comes to artificial intelligence, embodied computing is our kicker. It's the thing that allows us to launch off and do things that we never thought were possible for humans to accomplish. Now, embodied computing allows us to wear the computing, to embody the computing, and leverage that. Now, we can see how impactful that is when we think about the physical ergonomics of embodied computing. For example, this glove, built by General Motors and NASA, called the Robo Glove. Now, this hand that this person is wearing is actually a really sophisticated robot that was designed for the International Space Station. That robot required a lot of training and specialized knowledge to be able to use that tool effectively in these types of unconstrained, unpredictable environments. But what NASA and GM did was they created this wearable glove that allows the operator to control the robot simply by moving their hand, not by having to program it or control it. Instead, they're just moving their own hand, and with the effort it takes them to lift 5 to 10 pounds without the hand, now they can lift 15 to 20, and they can continuously do tasks throughout the day without creating fatigue on the behalf of the wearer. It also allows us to, as Lama was saying, train these intelligent systems in situ to create adaptability for the artificial intelligence. We can do the same thing when we apply cognitive ergonomics. Cognitive ergonomics basically reduces the mental steps required by leveraging existing cognitive functions of the human brain to amplify its mental output. Now, the brain uses multiple senses and movement as the raw materials. So if we can deliver the computer data in a way that naturally is expected by the brain, we are reducing the amount of friction between the human and the compute and allowing them to leverage that innate cognitive function of the brain, such as spatial cognition or other types of those innate cognitive functions. Now, vision is maybe one of the easiest to talk about because we have so many tools that are geared towards vision. And when it comes to embodied compute, XR becomes to AI what the monitor is to the PC. It allows us to see the AI splayed across our world in a very intelligent way. And it allows us to see through machine vision at the real world. And as a result, we reduce training time, such as this tool created by Scope AR and Lockheed Martin. What this did was took a 30,000 page training manual and reduced it down into a visual cue that the wearer looks through to see the task, and it reduced the training time of creating this Orion spacecraft engine by 86%, which is a huge improvement in time to retention and action. But XR also unlocks new human capabilities because of the ability to sort of embody that intelligence. It feeds us directly to our visual cortex, which is a huge part of our brain, simply by taking the screen and putting it up against our eyes. Now our brain uses that intelligence or that vision, machine vision, as if it's real world sight, which allows us to do things such as transcend pain, as well as rehydrate neural plasticity. Now, neuroplasticity is the brain's ability to rewire itself to create new neural pathways. And when we combine both the physical and the cognitive ergonomics, we unlock entirely new human capabilities that we never thought were possible before, such as this project called the Walk Again project from Dr. Nicholas. And what they did there is they put an EKG cap on top of the, or EEG cap on top of the wearer. that was particularly picking up sensory data from the motor cortex. That's the part of your brain that controls your legs, arms, etc. And they trained these paraplegics to use that portion of their brain to control a pair of avatar legs. So now the machine vision is showing the human controlling the legs with that part of their brain. Then they connected a robotic pair of legs to allow the human to feel the sensation as well as see the sensation. And after about 6 months, all patients started to regrow the musculature system. So the brain had created a new neural pathway between the brain and the legs that then allowed all 8 patients to have voluntary leg movement without wearing the apparatus. They had created a new neural pathway to walk again. Now, this happens because neurons that fire together wire together. And if we want to unlock new human capabilities, new human ingenuity, what we need is to develop that kicker that allows the human brain to craft these new neural capabilities. So the key takeaways I want you to think about is that we have to be conscious of the tools we are creating and how they will shape humanity. We can leverage physical and cognitive ergonomics to reduce the specialized knowledge required for humans to leverage AI in meaningful sort of ways. And that by combining those things, we can create dramatically new human capabilities by allowing us to embody compute and create that kicker that allows humans to do unheard of things because we're using AI as the jumping off point, not the limiter. So my questions to you are, how might we leverage this type of HMI to increase participatory inclusion in AI economies? And how might we create AI tools for vocational workers that amplify human capabilities to new economic benefits? Thank you.